Hello everyone, I am Dr. M. Manikam, Assistant Professor, Department of Physics, Dr. SNS Rajalakshmi, College of Arts and Science, Coimbatore. So in this video, we will detailedly discuss about choke coil. So how it is constructed, choke coil, how it is constructed, and what is the principle of working principle of choke coil. Then what are all the equations are involved. Then where we are using this choke coil and what are all the applications of choke coil. So these are all the things we'll discuss in this video. So let's get started. So choke coil means it is an inductance coil which is used to control or reduce the AC current without major power loss. So this is the main advantage also. So it works by offering inductive reactance XL, that is equal to omega L, that opposes the change of current. So this is the working principle of this coil, I mean choke coil. In a practical choke, a small resistance R is present along with the large inductance L. So the shape of the inductance, I mean choke coil, is the large number of cycles wires are uh, surrounded in a coil. So the construction for the choke coil is several turns. Already told that the several turns of insulated thick copper wire wound on a iron core. So iron core is made up of, iron core in midpoint is there, and around the iron core, so there are several turns of copper wires are winded. So core is laminated and coated. So by using the, for example, a shellac is used here to minimize the eddy current losses. So the core, I mean iron core, is laminated using the material, shellac materials. Then materials with a high permeability, that is for example stolai, so large inductance with small currents. This kind of mechanism we are using. So low resistance, that is R, is small, then large inductance L is large. So this is the construction of this choke coil. Then the why the power loss is small. So what are all the mechanisms we are using or following for choke coil, so to reduce the power loss. So this why, what is the reason for this, we will discuss. So inductor stores energy in magnetic field, that is W is equal to 1 by 2 L I square. So when current is rises, okay. So inductor stores energy in magnetic field when current rises. So most of the energy is returned to the source when the field is collapses. So that's why the power loss is very small. So the only small losses occur due to, so the following reasons: the copper loss, that is I square R in the coil, small amount of resistance only is there, so it is power loss is also small. And then core losses, so hysteresis and eddy current losses is there, so it is reduced by laminating core. So we are laminating the core ion, so we will reduce those current losses also. So these are the reasons, so why the power loss is very small or minimum. So this is the comparison between using ohmic resistance and using of choke coil. So if you are using ohmic resistance, means it reduces the current by dropping real power across, or I mean resistance. Here in choke coil reduces current using the reactance XL, that is equal to omega. So no real power is ideally, no real power we are using here. So then large power wasted as heat. So in ohmic resistance where heat is produced, so power loss is equal to I square R. So low efficiency only we can obtain by using the ohmic resistance. Then very in choke coil, very small power loss. So P is equal to V RMS into I RMS. That is cos phi, with the cos phi value is equal to 0. So here, so very low power is lost. So high heating in ohmic resistance, high heating, bulky and insufficient for continuous use we are so because it is get heated. So this is the problem in ohmic resistance. In choke coil cooler operation, that is the energy stored in field, so largely returned, so there is no heat is produced here, so no problem for the heat issues. It is suitable for ohmic resistance is suitable for DC, not ideal for AC regulations. But choke coil works only with AC, ideal to control AC currents. Then core losses minimized by laminations. For example, eddy currents and low hysteresis materials we are using here, so reduce the power losses. So these are the advantages of using choke coils. Comparison between ohmic resistance, choke coil is the best one. So these are some applications of choke coil. So first one is current limiting or regulation in AC circuits. We are using this kind of choke coils. Ballistic for discharge lamps, mercury and sodium vapor lamps. Then fluorescent lighting. So this is the purpose we are using this choke coil. Then filters and smoothing in electronics, power supplies, legacy or line frequency choke purpose. We are using mainly for it is used for filter purpose. So these are the some applications of choke coil. So so, so this is the equation for principle and block diagram and mechanism of the choke coil. So this is the black diagram for choke coil. So the copper wire is winding in the iron core. Then when supply the energy, the magnetic flux is generated. So the power dissipated in the choke coil is given by, that is P is equal to 1 by 2 E naught I naught cos phi. So cos phi is equal to R divided by square root of R square omega square into L square. So this is the power factor of the choke coil. So by using the equations. So thank you. So thank you for watching this video. Thank you.